Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Stefan from Business Review, and I will be your host. It is our pleasure to have Smiths Interconnect with us today, who will be presenting this webinar titled Today's Challenges and Opportunities for Sustainable Railway Transport Connectivity. Today's guest speakers are Alan Garrick, Product Market Director at Smiths Interconnect, Riyad Gazdawa, Global Key Account Manager at Smiths Interconnect, Jean-C Lefreux, Engineering Manager at Smiths Interconnect. Before we begin, I'd like to welcome you to our webinar platform On24. You will notice that this webinar is browser-based. If you happen to disconnect for any reason, you can just click on the link you received via email to rejoin the session. To ask questions, you can do so via the Q&A widget on the top right-hand side of your screen. Just type your question into the box and click Submit. We'll allocate some time at the end of the session to address any questions or thoughts you may have. You can also use the yellow help widget if you require any assistance, and please keep in mind you can move, resize, and maximize all the windows in front of you for a better view of the slides. But now please allow me to welcome Alan.
Thank you, Stefan. My name is Alan Garrick. I'm very happy to talk to you all today. Thank you for your time, and I hope that you will be interested by our webinar. Riyad?
Hi, everyone. Good morning, good afternoon, everyone. This is Riyad Gazdawa. I'm Key Account Manager, and I look forward to address these topics around the challenges in railway rolling stock market. Jean-C?
Yeah, good morning, good afternoon, everybody. My name is Jean-C Lefreux, and I'm Engineering Manager for Rail. I'm very excited to be there today with you, and I'm ready to introduce main challenges and solutions. However, before we start, I suggest we start by a short survey.
Let's send over then to Stefan now.
Yep, thank you very much. It is now time for our first polling question for the day. If you'd like to vote, please just select the answer that applies to you and click Submit. So this polling question reads, within these subjects, where do you expect to have improvements? The first answer being high-speed connectivity, simpler to utilize and robustness. The second answer is higher speed connectivity performances. The third answer is power connectivity, higher performances. The fourth option is power connectivity, smaller size. And the second to last option is signal connector, miniaturization need, and we also have the option for another. So now let's take a quick look at what the results are. So 50% of the audience voted power connectivity, high performances, and we have a 25% split between higher speed connectivity performances and high speed connectivity, simpler to utilize and robustness.
So it's interesting to see the input of the audience. Thank you for that. We see that the power connectivity seems to be one of the key subjects today. We will discuss around this. Do you have any comments, Riyad, on your side?
We plan to talk about all of them today, but yeah, it confirms what I was thinking, honestly.
Thanks, Jean-C, on your side. Interesting, yeah.
We will speak about power connectivity, yes, in the third part for sure.
We will address this subject, so this is good. Huh? But thank you for your input. There will be other survey after, and we really appreciate your information. Huh? So railway transportation is winning some significant success, especially in Europe and in Asia, since many years. We believe that this success will continue as it is one of the cleanest means of transportation. Furthermore, the pandemic situation has been an accelerator on the attentions towards the environment. All these aspects, we believe, will remain and reinforce even more the railway transportation compared to other means. However, several challenges remain to increase the efficiency and the profitability of the railway market and the railway transportation. So please, Riyad, could you give us more details first on the main trends of this market? And beyond these trends, what are the future needs and requirements for the railway market?
Thank you, Alan. You said megatrends and requirements, right?
That's right.
I'll mention a few megatrends that you can see already on the slide. So the first one I would say is and it's the main one from my perspective, is the demographic growth and the urbanization trend that require a constant increase in trains, number of trains and trains density. The second one I would say is the high-speed trucks interoperability. I would say interoperability in general, especially in Europe, and that will add more complexity from my perspective in signaling features. The third one is the increasing of the number of passengers per train, and that's a problem that all the operators around the globe are facing every day. And I would finish with the megatrends with the development of smaller and private operators that will manage the small itineraries and, for example, the small itineraries, I think, and that will emerge more and more in the future. So from the requirements perspective, I have three to talk about. The first one is the efficiency of the railway transportation, efficiency in terms of technical efficiency, and then the flexibility of this means of transport, because it's required to transport people between downtowns, and that give it a major assets, I think, versus the other transportation means like the cars or aircraft. Cars because of the environmentally friendly, and that's a very important requirement nowadays. The second requirement, key requirement, is safety and security. They are key, and they make the signaling very important and complex. It's reliability, basically, and this is the most important parameter to manage the traffic in the best conditions. And to finish with the requirements, there is more and more services required, as you know, that we propose to the passengers, like traveling informations, reliable traveling information, onboard TV, Wi-Fi on board, and these are the three main requirements I wanted to point out today.
Thank you very much, Riyad, for this overview on the trends and requirements in the railway market. So during this webinar, we will focus our discussion around three main topics, providing our feedback based on our expertise. The first topic, how high-speed data transmission can improve operational efficiency. The second topic, how complex electrical power requirement can be managed safely and efficiently. And our third topic and last topic of the webinar, how can miniaturization and space saving help increase number of passengers in the train? But before addressing our first topic, again, we need your support, your input, and we have other survey to address. So I will hand over to Stefan. Thank you.
Thank you very much. So this is our next survey for today. The survey reads, what does high speed mean for you today? Less than 1 gigabit, 1 gigabyte or more, 5 gigabytes or more, or 10 gigabytes or more? What results are you expecting on this one? Sorry, Alan, what results are you expecting for this polling question?
For this one?
Maybe need to refresh.
We need to refresh the screen.
Let's give the audience some more time to vote. And in the meantime, what results are you expecting?
On our side today, Riyad, what do we propose? Around more than 1 gigabit for sure, 5 gigabits per second.
I think, more than 1 gigabit for sure, and there is probably some applications requiring 10 gigabit, around 10 gigabit, maybe not higher than 10 gigabit today. Yeah. Let's see. I don't want to influence the answer.
Fair enough. Let's take a quick look at the results. So 47% voted 10 gigabits or more, 35 chose 5 gigabits or more, and 17% selected 1 gigabit or more.
Okay. Yeah. So it shows that the demand is there. We have no doubt on this. This is the view of today. Huh? By the way, we have another question. What are the needs for the future? Huh? So we can go to the next question, maybe.
Yeah, let's move over to the second question, which is what does high speed mean for you in the future, 5 to 10 years from now? Less than 5 gigabits, 5 gigabits or more, 10 gigabits or more, and the last option being 4 gigabits or more. So do you have any thoughts about what results we might get on this one?
If we give our thoughts, we will influence the audience, but I would say yes, more than 10 gigabits for sure.
Yeah, me too. I would say 10 gigabit plus. Maybe not higher than 40 gigabits in the first step. Yeah. I mean, next 5 to 10 years. Yeah.
We can go to the...
Let's just give everyone 5 more seconds so they have enough time to vote. And then we can quickly take a look at the results and discuss them as well. Okay, so let's take a quick look at what everyone voted on. 61% voted 4 gigabits or more, 30% agreed with you on the 10 gigabits or more, and 7% selected 5 gigabits or more.
Very interesting. Thank you for your answers.
Especially for the 40 gigabit plus, I was not expecting that. I was thinking around 40, but not higher. But it's fine. It's good to know. Thank you very much to the audience.
So, thank you. We will then address our first topic that is fully in line with this survey. Okay, so we notice an increasing demand in high speed, and it's just shown a few minutes ago. The data transmission for onboard communication is more and more required. Why? Because there are more control and maintenance needs. Critical information must be transmitted quickly for safety and security reasons, and we have an increasing demand of communication to travelers. 2 options are presented to increase this, to manage this transmission, high-speed transmission. Fiber optic is one option. It shows exceptional performances, as we know, but it's fragile, complex to implement, and sensitive to vibration. The other option is copper, that remains excellent, with a constant transmission improvement, and it remains a very cost-effective solution to manage high-speed transmission. However, there are challenges to consider when we are using copper for cable transmission, and we would like to enter in more detail on this. So maybe Jean-C, you can tell us more about this subject.
Yes, absolutely, Alan. For environmental and safety reasons, the first challenge I see, and especially in case of fire in tunnels, is that the rail market is using fire and smoke cable, and also some cables without halogens. If you have a look on the slide, the picture is showing that fire and smoke cable have a large external envelope and big external dielectric diameters. If you compare these dimensions to industrial cables, you can clearly see that these cables is bigger. On the other hand, due to the miniaturization on the trend, you can see that the copper section is decreasing. And so it means that we have to cope with big external envelope, but also with smaller and smaller copper section.
So as we see here on the picture, the cable that are significantly different. Huh?
Exactly.
Okay, thank you. What are the impact of such cable design at connector and contact level?
Clearly, the main impact is that those electrical high-speed contacts have to be dimensionally compatible with a large envelope, large electric material, and smaller copper section. The main challenge is that we must keep a very stable impedance. You have seen on the screen that the stable impedance depends on the diameters, and you can see on this animation that the electrical field can move by geometry change. So you can see some different color change when the signal passes through the electrical line, and especially when you have geometry change, you can see some red or orange points. This point is very, very important. Yeah, clearly. This is a very important point.
Again.
Up, geometry change, and then you've got a red color. So this is a very important point to avoid impedance mismatching, because any impedance mismatching can disturb signal transmission. So clearly, to manage properly high-speed management, we are able to use some simulation tools, and we simulate high-frequency performances on electrical cable and contacts at early design stage. For high-speed pairs, especially, disturbance between electrical pairs is called crosstalk with fixed and next parameters, and we can also simulate fixed and next parameters by simulation. And I should say that when simulation is successfully achieved, we can measure first prototypes, first series, as you can see on the picture on the right. So this is done typically with vectorial analyzers.
Okay, thank you, Jean-C, for this information. What would you see as other effects on high-speed transmission?
One very other important parameter, Alan, is the reliability versus the full life cycle, and to maintain and control the TCO, I mean the total cost of ownership. So typically, to reduce maintenance and electrical failures, one solution is to design a robust interconnection system from cable connection to electrical contact connection. For that, a cabling fixing is mandatory, and typically it can be achieved thanks to a robust cable clamp system that permits to connect efficiently the cable shielding brain. And for sure, a good EMC connection is achieved with a shielding brain connection over 360 degrees, as you can see on the picture on the left, below on the left.
On the left down, okay.
Yeah, exactly. To manage properly reliability, qualification activity is key, and connectors for rail are tested according EN 61373 standard. And most of time, we take the more severe conditions. Even if an electrical and electronic equipment is installed inside wagon, we test our connectors according to level 2. And the level 2 is in fact the level simulating installation at the surface of bogies or wheel track for American colleagues. So during this qualification activity, high frequency performances like attenuation, return loss, crosstalk, we have just spoken before, higher diagram can also be measured during qualification activity. For sure, to pass such high vibes for rail, and especially because vibes can provide some freighting corrosion issue, this is very important and key to use proven and reliable contact technology like hypertack technology you can see on the picture at the top on the left.
Yes, and just under we see our vibration testing tools.
Yeah, exactly. Yes, it's few pictures showing that vibe is key.
Okay, thank you, Jean-C. This is very interesting to point out the importance of the, as you mentioned, the total cost of ownership, using proven and qualified solutions for railway environment and customers' application. Would you see other total cost of ownership aspects? Maybe Riyad, you can mention something about this?
Yes, sure, I can take the point. Actually, I think the other very important point for total cost of ownership is the termination, the harnessing, to have it quick, easy, and reliable. Obviously, that must be managed without mistakes to avoid further recabling and then overcosts, and keep the performance safe. So I have, or we have as a company, simple solutions that we consider as best practices to resolve that. And I would say the first one is the smart design itself, because that allows a high-speed contact termination within few minutes, even though that's a miniaturized quadrax Ethernet contact, for example. So smart design is the first thing. We use plastic inserts with color coding. What we call color coding is what you can see on this slide on the top, on the left. So you can see that you put the yellow wire of the cable in the yellow cavity, and you put the blue wire in the blue cavity. Basically, that speed up the assembly and avoid any mistakes. And I would say the last one is giving a clear assembly termination to our customers and the users with reminders of the best practices in terms of cabling and termination, and that helps to train the workers and help them to speed up the process and make it repeatable. Yeah, and actually that I think all these points help to, from my perspective, to secure the performances along the harness life cycle. And as it's a sensitive, I think, harnesses, I mean high-speed harnesses, they are very sensitive. So any sleepage or mismatch in cabling would affect the impedance, as Jean-C was explaining, and that could affect heavily the performances. Yeah.
Okay, thank you, Riyad, for this input. So this last slide close our first topic. We keep in mind the cable and connectors dimensions to be managed properly. Was just mentioned by Riyad, the impedance aspect. Simulation and testing during development phase are mandatory, extremely important to achieve this task. And the contact quality, interconnection between cable and connectors with robust processes are extremely important. I think I will hand over to Stefan for the next survey session. Stefan?
Yep, thank you very much. As you mentioned, it's now time for our next polling question for today. This question reads, what does high power mean for you in terms of amperage? 100 amperes or more, 300 amperes or more, 500 amperes or more, 800 amperes or more, or do you have another option in mind? I'll just give everyone a couple of seconds to vote. Similarly to the previous questions, just select the option that applies to you and click submit.
Wait a few seconds. Can we go to the results?
Let's take a quick look at the results. So we have 83% of the audience voting on 500 amperes or more, and 16% selected 100 amperes or more. What are your thoughts on these results?
I'm very happy to see that.
Very happy. Not a surprise. At least everybody nearly is aligned. Huh?
Yeah, it means we are proposing the right thing to customers. Yeah, it means we are proposing the right things to our customers. Yeah.
Okay, lovely. And now let's move over to the next polling question for today, which reads, what does high power mean for you in terms of voltage? 240 volts plus, 500 volts plus, 800 volts plus, 1.5 thousand volts plus, 3000 volts plus, or is it another option that applies to you? So what results are you expecting on this one, guys?
I'm expecting 1500 volt plus.
We will see.
But
yes, the voltage will increase. It's more mixed.
Okay.
Cool.
It's more mixed. There are 500 volts. Yes, it's what is used today. Tomorrow, yes, there will be. There are already some demand. 1,500 volts, 1,000 volts.
Yeah, I think I understand the result because 800 volt plus is metros and light vehicles. 1500 volts is intercity trains and can be high-speed trains, and 300 volts can be intercity trains and high-speed trains, but there is less vehicles using 3000 volts nowadays. Yeah, good results, compliant to our thoughts as a company, I think.
Mm. Exactly. So let's go to our next topic.
Yeah.
Related to electrical power management. Riyad, you introduce this subject for us?
Sure. So what I would like to say to introduce this topic is that in passenger vehicles, especially, the power distribution is included in all the systems of the trains. And actually, it's less and less locomotives nowadays pulling cars, you know. And you can see today there are more boxes, cables on the roof, under the chassis. Obviously, we still find electrical locomotives today, and even diesel around the world, pulling commuter cars. But on the modern trains being built by the biggest companies, for example, the motors are no longer in locomotives, but on bogies, on the bogies, or bogies is wheel track for my American colleagues. Bogies is more used in Europe. So, well, this change in the power architecture or the power chain architecture in rolling stock occurred several years ago for several reasons, actually. The first one was to gain more space for the travelers, and the second was to optimize the power consumption of the train and to make it safer. Safer because when you have the braking systems and the power system, I mean the motor on the bogie, in terms of inertia, it's much better than having a locomotive pulling the whole number of cars behind. Obviously, the motors are one example where power distribution is required, but the power is everywhere. You can have the air conditioning applications and other function all along the train. Yeah, this is to introduce the power for rolling stock topic. Yeah.
Oh, thank you, Riyad, for this information. We understand the complexity of the power harnessing inside the train. why do we need to connect? What do we need connectivity, and what are the challenges behind this connectivity?
So I invite you to look at the train picture on the slide that you have on the screen now. And by the way, Alain, thank you for the question. And I would say our customer need connectors to connect and disconnect things. As you can see on the screen, these colored equipment in the train, you need to connect them to each other. And now you're going to ask me why connecting and disconnecting these things? Why we need connecting?
Exactly.
I was waiting for this question actually. So this is basically related to how a train is built. Once again, look at the picture. As any vehicle, considering the complexity and let's say the modularity, in a train, for example, there is a certain number of cars, certain number of systems, and you have then the bogie, you have the transformer, the seats, the motors, and for all these systems, these equipment, there are different suppliers. The supplier building the motor is not the one building the converter, for example, but you still need to connect them together, right? For doing this, you need a good connectivity that allows for an easy and fast assembly of the train. So rather than wiring inside the motor, so you can see the good man on the picture, instead of looking for what wire going where, so he will have a connector that he would be able to plug and play. So yeah, basically, rather than going inside the equipment, the motors and the converters or any other boxes, it's much easier to make a solution ready to use it in the manufacturing phase, and that will for sure make simpler the maintenance phase as well, and then yeah, save time, save and mitigate risks. Yeah, this is what I can say about that.
And concerning the challenges.
Yeah, sure. So the challenges with the power are mainly the amperage and the voltage that generate temperature rise and over voltage issues, and that is obviously influenced significantly by the environment of the rolling stock and the utilization of the equipment. So as you can see on the screen, how the environment of can be dusty and yeah. Yeah.
Okay, so maybe we understand so that there are some needs of modularity, of course, and amperage voltage is the challenge. Do you have any beyond this 2 amperage and voltage issues? Do you have any other comments on your side?
So Alain, it's a good question because yeah, I talked about the voltage and amperage, and those are what makes actually what condition the performances of the connectivity solution. But the challenges we have others, which are, for example, the size of the connector, and the challenge of the environment of the rolling stock application is a challenge as well. So if I may, obviously I'm talking about this as challenges to provide sustainable solutions that a train could operate during 20 or 30 years plus with, actually. So maybe to talk a bit more Go ahead. Okay, so
yes,
let me just maybe.
Yeah.
I will hand over to Jean-C maybe to talk about more technical details about the amperage and voltage and others.
Thank you, Riyad. Yes, for sure. I can detail a little bit more the impact of electrical current on electrical contact. And you are right, electrical resistance and high current are the source of temperature rise in electrical lines and so in power connectors. So for that reason, this is very important to control and limit the full electrical resistance. Even if the connector by itself can help to dissipate the heat, there are other multiple parameters as described by Ohm's law, you can see on the picture. The first very important parameter is the conductivity. This is the resistivity inverse. Of course, the bigger the contact size is, the better the conductivity is. If we use some good conductive material like copper alloy, but especially pure copper for power application, we can improve electrical conductivity. The second very influent parameter is the surface. The bigger the surface is, the lower the electrical resistance is. For that reason, this is important to use some elastic contact offering large surface of contact. If you combine a large surface of contact with good conductive plating, again, you can decrease significantly electrical resistance and therefore temperature rise due to Joule effect. On the picture at the middle, you can see a high power simulation that permits to see where are the temperature rise inside an electrical contact. And on this example, we can see the hot point thanks to the simulation. We can also do some measurements to double check simulation, and we can check temperature rise versus amperage on the full connectors. The last influent and very influent parameter I see is the cable and the cable interconnection with the contact. Typically, you know, of course, this is done by crimping, and sometimes crimping connection can be the limiting factor on the full electrical line, especially if the cable is having a limited section. So typically, we have to control the crimping that can be impacted or affected by wagon movement, and this is what we are checking with swing tests. So I wanted to point out that cable interface was key, and we mustn't forget that during the design and also during the connector selection phase. So in theory, and to summarize, a larger contact is better with good conductive material and good plating, and with a large surface of contact. But as explained by Riyad, we are facing with some connector size issue. And I should say, unfortunately, the rail environment is very dusty, and the nominal and over voltage are very high. Typically, we are speaking about, I should say, around few hundred to few thousand volts for nominal voltage. And for dielectric withstanding voltage, we are around few thousand volts. So this is very, very high level of voltage. And clearly, dust and high voltage, Riyad, have a big impact on connector size. What do you think about that, Riyad?
I think you are right, Jean-C. And actually, that doesn't make the connectivity very compact, doesn't help to make it very compact, because that requires long creepage distance and clearance. You will probably address in few seconds.
Absolutely.
The well-known standard to comply with is the EN 5124 in terms of creepage distance. Jose could explain it a bit more scientifically speaking. And there is no unlimited list of plastic material we can use because of these performance required. And moreover, I would say, as you probably know, the plastic material for electrical components in railway must be qualified, compliant, and tested to fire and smoke and toxicity standards. So the standards we are talking about is the EN 45505. So the most famous one is the -2, and that even shorten more the material list actually. Yeah. So it's challenging.
Okay, thank you, Jean-C and Riyad. We keep in mind to close this topic. The quality of the contact is key, the size of connectors in limited space and harsh environments. The simulation tools always needed and extremely important, and smoke and toxicity has to be, of course, considered. Let's go to our last topic on the miniaturization, and let's focus now on also on space saving, miniaturization. The rolling stock complexity increases, as mentioned in the two first topics, as you see. The main objective of the operators remain the same, how to transport more passengers with safety and comfort. So Riyad, could you give us some example where the main issues are related to space savings? And I know that you have seen some recently.
Yeah, long story short, Alain, all the areas, or several areas, and I would say even all of them, are impacted by the miniaturization, especially on the power. Signaling and control command devices as well, because they must provide more features, and in the meantime they are installed in very tight, reduced space. Yeah.
Okay, thank you, Riyad. Jean-C, could you, on your side, provide some inputs on these examples?
Yes, of course, Alan. Concerning connector evolution, clearly, thanks to new design, we can reduce significantly connector size. As you can see on the picture on the right, you've got some current floating connectors. On the left, this is a new design we have just qualified with the same number of contacts. And moreover, as we have spoken at the beginning, we have introduced 2 additional high-speed lines in the same connectors. Clearly, the key point to manage miniaturization is the clearance and creepage distances management. So on this picture, you can see creepage and clearance distances. Creepage distance is the shorter distance at the surface of plastic insulation material between 2 conductors. This is the blue curve you can see on the picture. Creepage distance prevents from degradation due to nominal voltage or continuous voltage. The other one, the clearance distance, is the shorter and direct distance between 2 electrical conductors. This is the blue line. The green line you can see on the picture. Clearance distance prevents from degradation due to some over voltage. So clearly, this is key dimensions, but there is also some other parameters like the environment. The environment can provide different pollution, which is called pollution degree. And this is key to choose correct distances depending on the pollution degree. This is described in some standard tables you can see on the right. However, you have to keep in mind that sometimes some application or customer ask more than the standards. Another very influent parameter is the material choice. Some materials have better electrical surface performance. This is typically called CTI for Comparative Tracking Index, and it appears in the table by material group 1, 2, and 3. So clearly you can see that depending on the pollution, depending on the material choice, you can decrease or increase creepage distance. And so our target is to choose good material to decrease creepage and clearance distance and increase density and decrease connector size. So combined with some smart design, for sure we can reduce connector size. So we can add some walls, as you can see on the picture on the left. We can add some holes, some walls or some slots to increase creepage distance and so keep small or reduce the pitch between electrical contacts.
Okay, thank you, Riyad. Just very fast, can you tell us what size reduction we can expect based on using the right material with the right design?
Thank you, Alain, for this complex, not easy question. Because as I have mentioned before, the pollution, material choice, connector size, voltage influence. But as you can see on this picture, we succeed to reduce around 30% the connector size for this application, but also the same for power application.
So interesting, significant size reduction. Do you have any other areas where you believe we can save space in the rolling stock?
Yes, there is one, which is the electrical cable architecture that is sometimes very and more complex because of the number of cables. So I should say that all options that permit to reduce the number of cables for sure will help to save space by reducing the number of cables on the cable interconnection level. So one very interesting option is to replace cable interconnection by a direct connection on PCBs, printed circuit board. The main challenge I see with the direct connection on PCB, Alan, is that we have to keep a very high robustness, and we need also to keep a blind mating function, especially when electrical racks are mated in electrical cabinets. To manage properly PCB connectors interconnection, this is key to manage miniaturization I have shared before, because PCB connectors have to be compatible with high density PCB, but they have also to be compatible with more and more electrical function, and also with high speed management we have seen on the example before. So again, to manage PCB connection, this is key to know and to take into account creepage and clearance distances. And as we have spoken before, it is also key to take into account some robust and reliable contact technology to support high vibes.
Okay, thank you, Riyad and Jean-C. We keep in mind the device size reduction. We heard the percentage of 30%. The right design and right insulation materials are required, and simplification of harnessing architecture. So let's now sum up our webinar after these three topics addressed. We have addressed several aspects of the railway market challenges and opportunities, such as increasing needs of high-speed application, the increasing power management complexity, and the miniaturization requirements. Jean-C, do you have any last comment to address to the audience?
Yeah. Today we have covered multiple subjects showing the main challenges, main solution we can address, but in a very short time, so we didn't cover everything. And probably some other aspects like filtering technology could be addressed later in some additional webinar because it may be an interesting, I think, subject, especially because of EMC management inside electrical and electronic equipment that are very sensitive to signal perturbation.
Okay, this is an interesting subject. Yeah, that we can address in another webinar. Riyad, on your side, any comments?
to finish the presentation, what I would like to say is that all the challenges that have been presented today are basically our daily works, and we have an heritage and expertise on all the sensitive railway applications. And last point, as you could see, this webinar hasn't been made as a product presentation, but I would like to finish with a slide that you can see on the screen now to give you an overview of our product portfolio, and that you can find on our Smith Interconnect website, so smithinterconnect.com. So just to make it quickly, you can see here, related to what we talked about today, you have power connectors and cable assemblies, circular and modular. You have high-speed connectivity, heavy duty or single contacts, and other technologies like the filter transient protections and the signal connectors. So the signal connectors that you can see, the rectangular plastic one, the REP is quite standard in railway market, especially in Europe. Yeah, and I think this is what I have for you today.
Okay, so thank you to present all these ranges implemented in the railway rolling stock. Yeah, but then now we have a little bit time to go to the question and answer phase. We have received several questions. You see them. You want to answer to the first question on the color coding of the cable?
Yeah, I can take this this question. Actually, the question is, which standard? Yes, let me read it properly. Which standard is followed for color coding of the cable? In reality, we don't have the standard to follow, but we build the connectors, we design the connectors according the cable. So if a customer wants to use a specific color for a specific color cable, we adopt the inserts with the right colors that are provided by the cable. So no specific standard for the color coding until now with our connectors.
Okay, thank you, Riyad. There is another interesting question about the EMI and EMC requirements that has to be considered on the design of the cable. Jean-C, you have any points on this?
Yes, I think there is two questions on EMC and EMI connection. So typically, why it is important to design an connection over 360 degrees? There are multiple reasons. The first reason is that by having a good EMC connection over 360 degrees, you are able to keep the more stable cable impedance, and then it permits to avoid some impedance mismatching. This is the first point. And by having a large surface of contact with the 360 degrees, you can manage and decrease properly the ground connection, so the contact resistance with the ground, and then you can easily capture the EMI perturbation and send them back to the ground. About the shielding, of course there are multiple tests, and of course we can do some tests according to some standard, and like shielding effectiveness measurements. But there is also some very impactful tests, as we mentioned before, especially for high speed, This is really very important to manage properly attenuation, return loss, crosstalk, to double check that the cable EMC and the cable EMC connection with the contact is at a good level.
Okay, thank you, Jean-C, for this answer. We have another interesting question for the future development of the trains. Apparently, more batteries will be used inside rolling stock. What are the challenges from the connectivity perspective linked to the batteries? Riyad, you want to answer this question?
Yes, I will take this question. I'll take the answer to this question. So it's definitely a real trend. We will have more and more batteries on the trains. You probably heard about the hydrogen-powered trains, and the concept is to get power, put it in batteries, and use this power from the batteries. And so batteries will be probably more and more with especially the light vehicles like metros and trams. So what I would say is we have solutions already in reality, still concept solutions to protect from a major risk. I think the major risk in this battery package, from our perspective, is the fire. When you have a fire, you can have big problems, if not disaster, in terms of material. So I think the main risk would be the fire. How to protect it? How to protect the equipment and the package from the fire with the connectivity? There is solutions with Smith Interconnect.
Yeah. Okay, Stefan, do we have time to take one last question, or we have to summarize and?
Yeah, unfortunately, I believe that's all the time we'll have for today. But if any questions didn't get answered today, please keep in mind they can be answered at a later date offline, so the speakers will follow up with you. So just leave me to thank our speakers for the great presentation and to Smith Interconnect for sponsoring this session. To the attendees, you receive an email shortly with instructions on how to watch the on-demand version of this webinar. You can do this on our website, which is www.business-review-webinars.com. We look forward to sharing more webinars with you, so please keep an eye out on the website just mentioned. And thank you very much for attending. I hope you have a lovely day.
Thank you very much.
Thank you.
Thank you.
Bye-bye.
Thank you for attending.